Coming in, joining us today, and thank you, Crystal, for inviting me in to talk about data quality patterns in the cloud with Azure Data Factory. That's me, Mark Cromer. I am a senior program manager on the Azure Data Factory team. I'm going solo here today, so I'm going to go through some slides, the presentation of what data quality in a Data Factory in Azure is, and then a bunch of demos on how to get started with it and how to build these patterns in Data Factory. And at the same time, I'm going to also try to switch back and forth and check for questions, and maybe Crystal, I guess, can help me out later on with that as well, since I seem to be a little go-to webinar unsavvy. But anyway, so let's get started. So I'm not going to spend too much time today going into details of Data Factory. I really want to focus today's hour that we have of time. I want to focus it really solely on how to start building and understanding data quality in Data Factory. And to be honest with you, even though I keep saying Data Factory, I think that I want you to kind of keep get the understanding that when you're going to build ETL patterns and data pipeline patterns of data quality in Azure, in the cloud with Microsoft, it's going to be on Data Factory. So that's kind of a, to be honest with you, saying Data Factory is a little redundant, and that's an already understood tool. So Azure Data Factory is what we think of as the data engineer sort of workbench or data engineer tool in the cloud in Azure. And I have a couple of pictures of the different parts of Data Factory on the slide. So what I was trying to get at here is that I could spend hours and hours and hours, and actually we have I have a whole offsite workshop I'll be doing the next couple of days in a different city. I'm going to be flying out to Chicago and delivering this session, and it takes 2 days just to get through Data Factory. And the reason for that is because Data Factory is such a broad platform for data integration, data movement, ETL, and data integration and whatnot. And so we're going to focus today on these two areas here, the mapping data flows and the wrangling data flows. Once you build some data quality logic in either of those areas, you will orchestrate those and you will schedule them in the orchestration piece, which is the pipeline piece. The pipeline part of Data Factory is where you combine all the different activities, the different things that you do with your data into a workflow. And we have complex workflow capabilities in there. You can have conditionals. You can do if then else. You can do loops. You can build schedules. You can have different kinds of triggers that trigger not just on wall clock scheduling, but also on other things like when files arrive, when files are deleted, and so on. And then the bottom is the monitoring. So once you develop this data quality logic and you schedule it to run, you can then monitor those executions, and you can see if everything's running and ensure that it is running effectively every day. All right, so top of this slide is the sort of important takeaway for this session, which is to say that as a data engineer, and I just realized I have the GoToWebinar over top of my, hey, I found the hide button. Check it out, very cool. Give me a second. There we go. Now I can see. Yay! So the important sort of statement for today's presentation is the top of this slide, which is that as a data engineer, you are responsible for building, managing, maintaining data pipelines that take raw data from multiple sources and produce refined data for business consumption. This the end result can be in the form of machine learning models, analytics, BI reports, etc. So the pipeline that's shown at the bottom, or the sort of ecosystem that's shown in the graphic on the slide, is very generic and generalized. This is something that we talk about in Azure Data, and we have for years. And in fact, we've sort of codified this in Azure Synapse Analytics, that is bringing together SQL DW, renaming SQL DW with Azure Data Factory, Azure Data Catalog, other tools of that nature, ADLS, Power BI. And what that gives you is this sort of ecosystem in a box. Now, when you're performing data quality projects, what happens is that you will need to make sure that that raw data is in a form and has the shape and the contents that are required for those end models and analytics. And with Data Factory, you will build that logic in one of the data flow capabilities, which we'll be doing today. And then after that, you will schedule those. Now, I should say that when you are working with data for analytics in Data Factory, you do not always need to schedule it. You could use wrangling data flows or even mapping data flows to generate a one-off set of files and data exports for analytics, and you don't need to schedule it. But the whole scheduling infrastructure and the monitoring and management of those pipelines is built into Data Factory. And advance, there we go. Okay, so when you start putting those together, it will look something like this. A lot of different areas here in Data Factory that we can't go into today, but I want to give you the overview of what things will look like. You will snap together the different sorts of things you want to do with your data. For example, you probably want to acquire the data that you want to that you need to examine and that you need to conform to a specific model. So you'll use something like the copy data activity for that. And then you'll want to master some data, clean some addresses, and then produce an ETL pattern in data flows in Data Factory as well. And that ETL pattern will do things like produce slowly changing dimensions. So you'll modify your dimension tables. You'll load your fact tables. You'll probably also update some control tables of things that have changed and things that have happened, and so on and so forth. So it'll look like that. Now, let's do a quick overview of the ADF components, just so that we level set. No depth on these things. I have at the end of this slide deck, I have some links, including the link to the slide deck on my slide share. So you'll have this as a reference to go back to and dig more into Data Factory. There's lots and lots of good material on Data Factory out on the web. I know Pragmatic Works has had sessions on Data Factory that are very good as well. And just search out YouTube and Google. I used to say Google or Bing, but you can always just Bing if you want to as well. And search for Data Factory, and there'll be lots of material on Data Factory to give you the other areas of it. So let's talk about the components. And when we're doing the demo, and if you're going to play along at home, you will see that these are the different components of Data Factory that we're going to interact with. The first and the most fundamental is pipeline. Or I should say the most fundamental is really factory. You have a factory that has pipelines. But when you're building out your ETL, pipeline is sort of the home base. You have to have a pipeline to be able to execute data flows. Data flows are activities that execute within the context of a pipeline. So pipelines have multiple activities. Those activities are strung together in parallel or sequential fashion that perform the actions on your data. That's pretty simple. Activity is the sort of autonomous incremental units of action of your pipeline, the things that happen within your pipeline. That can be data movement, data transformation. It can be control flow facilities like lookups for each, if then else. Okay, now here's where we get into some interesting things, and we're going to do a lot of work with these today. So data flows, of course, are the piece that we're going to perform the visual transformation logic. But what makes up the data we work with within Data Factory is a data set. So data set is the way that you go in and you define the data that you're going to be working with in Data Factory. So this will be used within today's context as sources and sinks, or sources and destinations, if you'd rather think about it that way. Sinks is just a term that we use in Data Factory, the same as a destination. Now you'll see that we say here that each data set is associated with a link service. So a link service now is the set of credentials that you use to define how you connect to that data source. So that data set that defines the source and sink is the shape of your data. Your data set will say things like, I have these 10 columns, and 5 of them are of type string and 5 are of type integer, and these are their names. Link service is where you're going to enter in your credentials. Now, a very common and emerging pattern in Data Factory that I definitely recommend is to store those credentials in Azure Key Vault. So that all you need to give Data Factory is just a secret, and then we can encrypt that and go and retrieve your secured credentials at a key vault. Data flows are where we're going to focus a lot today, so let's not dwell too much on it here, other than to know that this is where you're going to snap together your logic. You're going to glue it together end to end, and you're going to construct a set of transformation logic. That transformation logic is going to be focused today in this session on performing data quality on your data. And then we'll trigger these things. We'll set up schedules for them. We may not get to this part, so I think based on our time, we probably already have enough to cover. I do want to just touch quickly on integration runtimes. Integration runtime defines the compute that we're going to be using today. When you build a data flow in Data Factory, you are acquiring a Spark context. So we leverage Azure Databricks automatically for you in the back end as a managed Spark environment to execute and to debug and build your data flows. So you don't need to know Spark. We encapsulate all that for you, and we provide for you a high-level set of functions, expressions, and transformations. All you do is we want you to define your intent, what you want to do with your data, and we will take care of all of the underlying information code and management of those clusters for you. And to define that, that is an integration runtime. And there are other integration runtimes besides the one that we're going to use today. There are self-host integration runtimes so that you can connect to your on-prem data. And there are SSIS integration runtimes so that if you're using SSIS, you can lift and shift those into the cloud with Data Factory. All right, so I'm gonna do a quick time check. We're at 8:15. Sorry, it's 8:15 my time. I'm in Seattle, and so I think we're doing well. Now, okay, that was a real quick overview of Data Factory. I know if you're not familiar with Data Factory, you're new to it, you're probably like, Mark, this is crazy. This is way too fast. Slow down. I apologize. We want to focus today on data quality patterns. Within those different elements of Data Factory I talked about, we're going to be focused on data flows today with data sets. And then we're going to put those in context of a pipeline. Two different data flow types that we talked about again are mapping and wrangling. Mapping is where we're going to build the logic, the intent first. Wrangling is you work with data first within a spreadsheet environment, which is, if you're familiar with Power BI and Power Query, or Excel for that matter, it is Power Query Online built into Data Factory. So what do these patterns look like? What is data quality? All right, here we go. So this is where we get into some meat and potatoes of what we talk about data quality. Data quality in terms of a data engineer, which again, Data Factory is a data engineer's workbench in Azure, right? So data quality, there's two different areas I want to talk about. First, I want to talk about data quality for data warehousing. So if you are an ETLer, you're responsible for loading up data warehouses with ETL jobs for your job. I put down in here just 6 common things that you'll do daily that have to do with data quality. This is not a fully exclusive or inclusive list. There are other things, but what we want to talk about today is, number 1, you need to verify data types and lengths. The reason why this is important is because you are loading up a logical model in a data warehouse. And the logical model is going to have with it definitions of data types and lengths. And if those things do not meet, your ETL sometimes becomes brittle and breaks. So data quality in the context of data warehousing will allow you to meet those constraints and have resilient data flows and resilient data pipelines that don't break. You need to decide as an ETLer, number 2, how to handle nulls. So a lot of times you'll have also built-in table constraints on your target that say that these columns cannot be nulls. So you need to figure out within your pipeline, within your data flow, what do you want to do with nulls? How do you want to handle those? Do you want to replace them? Do you want to leave them as null? Is it okay to leave it as null because the target table handles nulls, allows nulls? Or do you want to convert those into a value, an NA, or perhaps a placeholder value? Maybe you have an early arriving fact without a dimension. Maybe you want to just put 9999 in there, for example. Okay. Number 3 is domain value constraints. And in this case, you may have a set of values they want to load that might be for a, let's say it's a column that is used for a lot of very important BI reports. And that column is a selector, and that selector is always within a certain value range. Maybe it's a rating. It's always 1 to 10. So you do not want to, you cannot, as a data engineer, produce bad data. And this is where data quality becomes very important, because life is not perfect and people are not perfect. And those entry values of 1 to 10 that you're going to receive on your source and your raw data coming in is invariably not going to be within that domain constraints of 1 to 10. And so you need to either take those rows out, or you need to modify them, or you need to tag them. And this is what data flow logic within Data Factory allows you to do. Number 4 is a single source of truth, master data. There's a lot behind this. We're not gonna talk too much about master data today. I wanted to put it on the list because it's very important. So another aspect of data engineering with ETL on a data warehouse is that you do not want to have the name Mark Cromer spelled 10 different ways and have the reports and the searches associated with that all produce different results. You need to have a single source of truth. You need to master that, so you need to come up with a way to do that. There are different techniques that you can do that in data flows. Probably what I'll do is park this one and I'll do some follow-ups. I have at the end of the slides, I have a reference slide on there, and I just realized I did not put my social media contact in there. I'll put that on there here too before I go over to the demos. You can always link up with me and on LinkedIn or on Twitter, and I'll provide some additional details on how to have some single source of truth pipelines as well. We just don't have the time for it today. I already mentioned late arriving. I called it early arriving facts, late arriving dimensions, same concept. And number 6 is lookups. So lookups are very important, because then a lot of times when you're loading data into a fact table, you may not always want to just put the foreign keys in there. You may want, or the surrogate keys in there. You may want to do a lookup against a dimension table, and you may want to replace the fact table with some values. So lookups are very important. These are all built into data flows within Data Factory. Now, the other sort of data quality we're going to look at today is data quality for data science. So as a data engineer, you're also going to need to do these things, and you're going to need to produce pipelines with data flows and data transformation logic that can handle duplicate data. A lot of times you get the exact same data in more than one row, and you're not aware of that, and you need to do some checks for that. You're going to need to have the ability to have what we call descriptive data statistics, number 2, or essentially be able to profile your data. And some of the common things that you do is look at the value lengths, the frequency distribution, which is number 3, the data type, I guess some mean, median, average, standard dev. The reason you'll do some of those profile stats is to understand the profile and the shape of your data, as well as possibly using those aggregated stats for replacement of null values. Because number 4 is missing values, and in data science, missing values can be handled will be handled slightly differently than in a data warehouse context. Because for producing, let's say machine learning models, for example, for data science, missing values can be very disruptive, and you'll want to either put in a special code for those, or if you have a series of measurements, you may want to replace nulls or NAs with a median or a standard deviation in there. Number 5 is enumerations lookup. So we had lookups in data warehousing for your surrogate key, your primary key to foreign key lookup. Very common in data science as well to replace coded values with enumerated values. So a lot of times you're going to get raw data that has codes in it that need to be replaced with categorical string data. So I'll show you how to do that today. And then value replacement, that's the same pretty much as in data warehousing. So what does this all look like? So last couple of slides here, and then we'll just look at this stuff live on the Data Factory. Let's look at data profiling first. So when you want those descriptive stats, on the left-hand side is mapping data flows. You will preview your data. Remember, this data is going to come to you live from Spark. The right-hand side picture is of Power Query Online, which is our wrangling data flow. So the context difference is left-hand side is you build graphs in Data Factory, and those graphs will define the intent of your data transformation. The right-hand side is working with data first, the spreadsheet mechanism for working with data flows. Both of these work very similarly, and both of these results in a data flow script. If I remember, I will try to show you what the data flow script looks like today before we go. Both of these produce the same data flow script that run on that same managed Spark environment, that same Azure Databricks behind the scenes, under the hood, managed by Data Factory. So your wranglings, your data flows built in Power Query on the right-hand side will execute in Spark at scale. Left-hand side, same thing. Notice also on the left-hand side, there's a drop down here under typecasting. So you can perform some quick transformations on data, both in wrangling and in mapping when you're in this profile environment. Replacing values, how do you do that? So this is an example here. What I like to call the if is an expression. If is a function within our expression language. This is an example of the Data Factory built-in data transformation language. So you don't need to learn Spark or Python or Scala. We handle all of that big data Spark coding for you. You give us the intent. Now what I did on the right-hand side is I have a picture for you in the slide deck here of all the transformations currently available within Data Factory mapping data flows. And these are the tiles that you put that get inserted onto your graph in the construction mode. And I'm pointing to I tried to point to the entry on the toolbar here. So derived column and aggregate, if you're SSIS developers, these should sound very familiar to you, or Informatica or Talent or any of those, same kind of thing. The reason why I'm highlighting those is because when you're replacing values, these are going to be the two transformations that you're going to want to pick out and work with. And this is what we're going to work with today. So for example, when I'm replacing any sort of value, I'm going to replace that column with a derived column. If I need to gather standard deviation or averages or means, I'm going to use aggregates. So I would aggregate across the entire data set and then use a derived column to replace that with an aggregate. And the second example I have here is replacing nulls. So we have isNull is a function, and you can put in the column name. And I'm saying here that if customer name is null, then replace it with NA. Otherwise, it's not null, so just keep the original value from customer name. Splitting, very common. You're going to do this a lot in data quality, because what you're going to do is you're going to say, if these values are, let's use enumeration for example. We could say if these values are, let's say we have it broken up by, let's say the data is split up by state. So we could have it 50 different ways, and we could say if the state equals WA, then do this set of rules against it. If it's CA, then perform this set of rules against the data. So that's splitting. Conditional split is what it's called within Data Factory, same as what it's called in SSIS. And the bottom is a new branch. So new branch will simply duplicate your data, which is very helpful to you and important when you're building data quality, because you may want to work on the same set of data 6, 7, 8, even just 2 or 3 different ways in the same data flow. In SSIS land, we call this multicast. In Data Factory, we renamed it as new branch. Same thing. All right, let's see, a couple more. Let's talk about pattern matching. I will show you this as well. Pattern matching is very cool if you need to perform a set of data quality rules. Let's say, for example, you know you're going to have strings come in that are always having extra white space in it. You want to trim them, but you have 500 columns. You don't want to build 500 rules, one for each column. We give you an ability to say, take every string or every integer and perform this set of operations on it. These 2 rules will work across all columns coming in, no matter what those columns are called, no matter how many columns there are. And I built that in 2 rules. And this is very important for large data. The right-hand side shows you that you could also transform data based upon ordinal position in the incoming data. So in other words, the takeaway from here is understand that you don't need to know the column names, and you don't need to work with every column individually when you're building these data quality rules in Data Factory. Now, I'm going to probably skip this because I'll show you this live. This is the example of building enumerations based on codes. You could use a case statement to hard code it, or you could do a lookup against a lookup file that has that in it. We're going to look at these data flows. These are available to you in pipeline templates. So in Data Factory are pipeline templates where you can take a lot of what I'm showing you today, and you can put those in your factory for you with the template. I'll show you that live. Then we'll do some fuzzy lookups. So fuzzy lookups are very important in big data environments because the data that is going to sit in your lake that you're going to need to provide some quality rules for is most likely going to be non-ideal. Let's put it that way. And so SoundX is a great way to look for things like titles and names and whatnot and match those together that way. All right, that's it. So let me go to this last slide before I show it to you because I promised to put my contact info on here and I forgot to. So let me quick type it in here. So on Twitter, you can look me up under at Cromer Big Data is my Twitter handle. And LinkedIn, I don't even know what it is at LinkedIn, but just look for Mark Cromer and you'll find me on LinkedIn. Please ping me on social media. I'm happy to help you out. I've got some other videos on here, other patterns besides data quality patterns. The slides are in my slide share, data flow performance guide, way too much info than you want, all available to you here. So go ahead and take that with you. And let me save this so I don't forget. And let's go into Data Factory now the rest of the time. Hey, look at that, I hit the bottom of the hour perfectly. I am on a roll today. I'm probably not going to stop for questions yet. I'll stop early for questions because I'm cooking right now. I don't want to stop the train. All right, so now we're in Data Factory. No time for overviews of Data Factory. So if you're new to it, we're just diving right in. I apologize for that. Again, go check YouTube and Google or Bing for other great material on Data Factory that's out there. I do want to step back and say one or two quick things. I mentioned to you pipeline templates. Go to the plus sign up here in your Data Factory UI under pipeline from template. When you click here, you look at the Microsoft templates. I'm putting out as many as I can, these transform with data flows. So a lot of these patterns, you don't have to build them. I'm going to show you how to, but you could use these as starters. So if you want the dedupe pattern, you want the distinct rows pattern. By the way, there's a difference, and I'll explain to you the difference. I know they sound similar. If you are performing some slowly changing dimensions, I have a type 2 in here too, type 1 and type 2. If you're loading fact tables, any of the stuff, just click on here. It'll add it to your pipeline. It'll add it to your factory. Remember, factory is top level. All the different elements of factory that I talked about are here. Pipelines, data sets, data flows, and templates. All right, so that's a great way to get started is pipeline templates. The other things I talked about, the data sets are here. Under connections, the bottom left is where you're going to see link services that define your connection to your sources and sinks. And integration runtimes is where you define your compute environments. And so just to show you what we're going to be working with today, let's take a look at my large cluster. This is one of the integration runtimes that I'll use. It's an Azure integration runtime, so it's in Azure, it's in the cloud. Under Dataflow runtime is where you can define the type of compute. So this is going to spin up an Azure Databricks that is memory optimized with 68 cores. You can set a time to live as well. Time to live will allow you to have a warmed pool of VMs for Databricks that you can use when you execute your data flows. Lots of information I'm throwing at you, and we'll have to do some separate sessions and all this stuff. Now I have my Dataflow debug turned on. I recommend you doing this. This is sort of when you're working, when you're going to perform some data quality rules, you're going to use data flows. Within Data Factory, this is the first thing you do in the morning. So you come in, you're going to start your project, turn that on. This will spin up the Spark environment for you. Again, you don't need to know anything about Spark. Don't worry about Databricks. We do it for you. It will take a few minutes for the cluster to come up. And when it does, you'll turn green. Your switch will be on. You'll be ready to go. So we're all cooking, ready to rock and roll. If you like Bob Ross, I have my canvas already with my magic white. I'm ready to go. So what you start to do is you start to look at building your data quality patterns. I'm going to start with a wrangling data flow. The reason why I'm going to do that is because I think that one of the most important things to do first is to understand your data. And wrangling data flow gives you a great way to do that. You don't need to add this into a pipeline. So I'll be honest with you, the way that I've been using wrangling versus mapping data flows so far, when I demo with customers, when I work with customer projects, when I do workshops, is I use wrangling as a descriptive statistics and profiling tool. Occasionally, I will add a wrangling data flow to my pipeline, but not always. Okay, so let me show you what I mean by that. So the first thing I'm going to do is I'm going to pick a data source. These are all those data sets that I talked about in Data Factory. I already have these created, so I have a movies file. This is a CSV file with movies data in it and ratings for those movies. I'm not going to set a sync data set because I do not plan on putting this into a pipeline right now. I just want a source data set. What that's going to do is going to launch me into Power Query Online. Now, when I'm using Power Query Online inside a Data Factory, this is an interactive spreadsheet first view of my data. And I have, because I use this all the time for descriptive stats and profiling, I already have profiling turned on for my wrangling data flows. So it's going to give me each column statistic right out of the box. Okay, you can set this under options, project options. I take that back. You can set that under options, global options, and I have enable column profile, and I'm just sampling the top 1,000. I think it's important to just get the top 1,000 rows because a lot of the data sets in your lake are going to be very gnarly and large, and you don't want to sit here waiting forever. The reason for that is because this environment right now, what I'm sitting in, when I'm looking at things like, let's take, for example, here is my genre for the movies. My genres are a multi-value string column, so they are pipe delimited, action adventures, sci-fi, for example, which is 20,000 Leagues Under the Sea, gets all three of these genre tags on it. So what's going to happen here is that this environment is all Power Query Online. There is no Spark involved in this yet. Spark does not come into play with the wrangling data flow until you add this to your pipeline and execute it from your pipeline. At that point in time, this will get compiled down into a data flow script and executed as a job in Spark. So that will execute at scale, okay? So when you work with Power Query and you want to do things like examine your data like I'm doing now, I see there are 237 distinct values, 124 of those are unique. When I click on this column and I look at things like, there's my value distribution. This is how many times drama appears, how many times comedy appears, how many times we see drama romance. Remember, this is multi-valued column. I can see how many nulls there are, how many empty strings. Now, when you want to perform something on this, like let's say, for example, let's go up to transform. Let's say I want to, I know what I'll do. Let's pull this down. And let's take out, let's just take out one. Let's take out comedies, okay? So if you want to perform a operation on your data like that, you need to have a sync data set. So I don't have a sync data set because I'm just playing with the data here. And when you add this to your pipeline, that rule that I just built, that rule that says remove comedy, that step will get translated into Spark and run on Databricks for you. Okay, so very powerful, but I just want to show you that this is a good starting point, is examine your data, look at your data, understand your data. You can look at how many are empty, how many are null, so on and so forth, okay? So that opens up as a separate tab. That is my wrangling data flow. Now that I know my data a little bit, let me go over into a movies data flow that I already have built. And I have that under here under movie demo. So when you are in the mapping data flow, and you would get to this from new data flow, mapping data flow. When you're in mapping data flow, you have a blank canvas. And you start adding sources. You click on add source, add source, add source, source, so on and so forth. You can add as many sources as you like. We do not limit that. And then you can join those, union them, use them for lookups, whatever. In this case, very simple. I took that movies data set within my wrangling. I looked at it in Power Query Online. I understand the data, so I know that this is a good data set that I can work with. This is just some simple analytics on that data. Now, to get that same view in mapping data flow, you just go to your data preview tab and you click refresh. This is going to put me into a similar data view of that data set. And under debug settings, you'll be able to tell Data Factory the same number of limits that you had in wrangling data flow. And I could say, just give me the top 1,000 rows here. Now in mapping data flow, mapping is always in a big data environment. Mapping data flow is always going up against a Spark cluster to work with. So you have to have this debug on, and it will go ahead and it will look at the data using Spark, because in this case, you may want to, instead of just look at the first 1,000 rows, you may want to look at all 9,000, I think there are in this data set. Now, I can see pretty quickly, pretty easily here that I have a bad year in this data set, and I would want to take that out for data quality purposes. But what I can do is I can click on that column. I need to refresh. I just realized I need to refresh because I changed the debug settings. So anytime there is a change, I can't perform an action on the data until I refresh it. So this is going to refresh. It's going to send the packet back down to Databricks, and it's going to come back with the data again. So on my year column, I can see that it's a text. Now the reason why it's string, it's text, is because it's a CSV data set. All of the columns within a CSV data set are going to always naturally be string, because there is no richness, there is no data type associated with CSVs. So I don't like that. I see under my projection, I see these are the columns that are coming in, and these all look fine. I'm gonna want to send these out to the data science team. But I want to associate some rich data types with that. So I'm just gonna click detect data type, and Data Factory will send this down to Spark and come back with inference of those data types for me, and will change those data types on the fly. So something like year should turn into an integer. The ratings should turn into integers. And then when I work with it, I can then say that, okay, I didn't say integer, they came with short, that's fine too. So now under data preview, when I look at my year column, and I have to refresh because I clicked, oops. You click refresh because I changed the data type, so you click refresh. Now you're gonna see year as a Schwartz, and then I can look at the stats on it. So what I want to do is I want to quick jump over, because I know I'm running short on time. I want to show you some more complex examples. So I can let this cook in the background. And let's go over and let's look at something like fuzzy lookups. So fuzzy lookups, actually, since this is here, I'm just going to stay here for a second since this is here. Now that I have the year column selected, if I click on stats, I will get similar stats that I got from wrangling data flow. And why it's important to show you this in mapping is because you don't need to swap back and forth between the two interfaces. You can stay here in a mapping and you can get the same sort of data. Now I set the limit to 1,000 in this case, so I'm only seeing 1,000. I see 0 nulls, but I only see that negative 1980 coming in one time, which is great. So what I want to do is I want to take that out. So to remove that, you use a filter transformation. So if you click on filter, so remember, this is the working model. You add your transformations from the toolbox with the plus sign, and you add that in context in your flow at the point at which you want that transformation. So let me walk you through that again. This preview of the data is from my source. So I know right away after the source it has bad data. Let's take out that 1980. I don't want to send that to the data scientist. I don't want to throw off their model. So I click on the source, I click the plus sign, I go down to filter. And now I'm going to write an expression. So I'm going to click on the filter on box, and now I'm in the expression builder within Data Factory. And what I want to say here is that the IntelliSense and the information on the left is a collection of all of the columns coming in, which can include columns that you have created with derived columns, plus columns from your source and anywhere else in your flow. So your columns, all the functions that are available to you, this is the function language that is in Data Factory. If you click on this link up here, you'll go to our documentation of the entire set of functions that are available inside of data flows. This is the data flow transformation expression language. But all I want to do is I'm going to take out that bad year. So really simple, this is going to be really simple expression. So the column name is year. So there are actually two types of year, because I have year as a column name and year as a function within the expression language. So I'm going to use the second one here. That's the column name. And now I'm going to make sure that year is, I'm going to say year has to be greater than whatever would logically make sense in this case. This is kind of setting domain values. And so I'm going to say year greater than, let's say I don't want any movies that are before the year 1920. So I'm going to say 1920. So now this will, and I can actually click refresh on this, and you can view, you can get a glimpse of your results of your expressions, and your transformations in line as you're building your data flows. So you can see that this filter will take out negative 1980, but I'm also going to take out 1902, 1915. And that may be okay. Maybe I don't want that in my model, but that also may not be what I'm looking for. The check mark means that these values are going to pass through this filter. So a filter is like your where clause in a select statement. So anything after this will pass through, but this greater than 1920 takes out too much. So I'm going to move this down to, let's say, 1800, and then refresh. And now I should be able to keep those early years and take out the negative 1980. There you go. So now I've got some clean data for that one. Okay, so I was going to go over to fuzzy lookup, but actually let me do this instead. Let's go over into my soccer ETL. Oh, by the way, on the slides, I also have on that last slide, I have a link to the sample data as well. And if I forgot that, I'll make sure that I put that in there. So all this data is free sample data that you can have to play with as well. So this is some, actually got this from Azure Databricks, their team, but this is some European soccer. I guess that makes it European football, right? This is actually soccer statistics of what's occurring during a game. And so this would be more of a data science. What we were looking at before is more analytics. This is more data science. This is probably going to look at taking, the different types of, I am not a soccer expert here, but let's say maybe hits or kicks or different things, different actions within a game. And perhaps you want to model that and produce some results of that machine learning model that could say that if you were to have, player A or player B in this position at this time, then your chances of scoring are increased by, 10, 20, or 20%. So this would mean that you want to look at things like, in this case, when there is no value for certain attributes, it has NA in there. And perhaps NA just blows up that model, and you might need to change that. So in that case, you could do something like you could do replacement on that. And so that value replacement will be done with a derived column. So I'm going to add, let me add it right here, right after the source. I'm going to add a derived column. Derived column is how you create or replace values. So that column that we're looking at right there with the NAs, let's go back to that. That is, okay, I'm looking at it right here. This is event type. Okay, so let's look at event type 2. This is event type 2. So what we'll say is on the derived column, we'll pull that down, so event type 2. So we're going to modify. We're not going to create a new one. We're going to actually modify this in line. Go to your expression builder. So you see I'm working on event type 2. And what we're going to say here is we're going to say if, or as you would probably pronounce it, if. So now we get we get some help on the function signature, but I'm going to take that stuff out. I'm going to say if event type 2, so you get the full IntelliSense autocomplete. Event type 2 is equal to NA. If it's NA, I don't want NA, I just want to send a null value over for that, okay? So event type 2 is of type string, and I know that by looking over here that I was wrong. It is actually of type integer. So event type 2 is integer, which means that it's not NA, it's actually null. So let's do this. Mark is way off on this one. This is actually null because it's integer. So we have a function called isNull. We're going to check for null of event type 2. I don't know why everything is slowing down for me right now. Apologize for that. If it is, then we're going to replace it with NA. Oh, because I was looking at 2 different columns. So I'm going to type this in, and then I'll show you what I'm talking about. So if it's null, I want to send over to the modeler, to the data scientist, I'm going to send NA. And if it's not null, I just want the original value. So I'm just going to put in then for the if condition, I'm just going to say event type 2. And my typing stinks. There we go. Close paren. We should have a valid Because I assumed that it was string. So let's see, event type 2 is definitely integer. Okay, that's fine. So we're gonna say if it's null, I can't send NA because it's integer. So let's send over, how about we'll send 9999. We're gonna send a special code along with it, okay? There we go. So if event type 2 is null, I'm gonna use 99999 as our special code. This is how you replace values with a either nulls or special values or codified values, in this case, based on being null. Otherwise, just send the original event type 2. So the reason why I got confused on that is because back here on my data preview, you'll see that with event type 2, which we are on here, those are nulls. So this is an integer. I was looking over here at a different one, which is string, which had NA. So that's player in. So let's go back to my derived column. Let's do that one next. So we can add, actually, you know what, I'm gonna show you this way. You can go right into the expression builder and you can work on a different column right from here. So I can add another column. And this was player in. Yeah, player in. So in this case, I'm going to say if, and let's do player in. So if player in is NA, this is what I'm going to do before, then I'm going to give you a null because you are accepting nulls for this. Player in. Man, my browser is like screeching out here. If it's not null, then we're just going to send the original value in there. Boom, there we go. Okay, so I have it as Boolean because I have it here. Let's actually change this to something new. In this case, let's actually create a new column. We'll call it player in 2. And here's the other thing I want to do. Player in, let's look at it here in the list, is a string. So when I'm returning null, I actually want to cast this. So we're going to say toString is null player in. This is, sorry, not here. My bad. Oh, because I said is null. Okay, it's early for me. That's my excuse. So we're just going to send null. Thank you. Boom. And close. And there you go. Okay, so if player in is NA, then we send a null. We're going to cast it to string, otherwise we're going to send player in. Okay, I am almost out of time, so I'm going to go for 3 more minutes, then we'll take questions. So that's value replacements. We also looked at the descriptive statistics. I have some other examples. Again, these are in the template gallery, so you can look at these as well in your own time. But let's take that movie CSV and let's look for any duplicate rows in there, because I don't want ratings for my analytics team to be duplicated because that'll throw the numbers off. So I have that movie CSV coming in. There it is again, and it still has that bad row in it. That's okay. I already showed you how to filter that out. So that's another rule I showed you how to build. So in this data quality rule, we're going to say we only want the distinct rows to be output. Okay. So what we're going to do is we're going to look at the original row count. So notice I have a new branch on here. I showed you this in the slide deck. This is saying that because I went from here and I clicked on this transformation on this source, I clicked new branch, that is duplicating the data on this row down here. So I have the exact same data duplicated. All right. So this top one is just giving me a row count. So I have what's called the select transformation here, which is aliasing this as original data, and then I have an aggregate. This is that aggregate transformation I talked about earlier, and this is having no group bias, so it's looking at the entire set of data, and the aggregate it's doing is just doing a count on it. So this is the same as saying select count from a table, and no group by on this. This is across the entire contents of data. And you'll see that the result I got is the count is 1,000. Why is it 1,000? The reason it's 1,000 is because in my debug settings, I've set my row limit to 1,000. Now, if I look at the distinct row count, to get the distinct row count, I first do an aggregate grouped by movie. Movie is my primary key. So I group by my primary key. And for the aggregate, I'm saying every other column, give me the first occurrence of that and count then the number of rows that are unique. So here is my aggregate counts for unique rows. And I just realized that I'm like misusing and I'm reusing the word unique and distinct throughout this, which is always interesting to discuss the difference between unique and distinct, but you'll have to forgive me. So the count of distinct is 997, which means there are 3 duplicate rows in there. And so at the end, I'm going to output the distinct rows. In this total count will be 997 distinct rows. So if you take this entire data flow and you plop this into your pipeline, it'll look something like this. Let me actually, while that's cooking, let me go ahead and do a pipeline. So let's do a pipeline while that's baking. Let me go to plus. Actually, it's done. So 997. So this is just the distinct rows out of the data set. So use this as a way to take out duplicates in your data set. You would use it by having a pipeline. Let's say your pipeline is first acquiring data, so you're going to copy some data from somewhere into Azure, and then you're going to run that data flow. You can go over here to data flows, and this one is called distinct. So we'll look for just distinct, and I'll spell it correctly. And there's my distinct rows data flow I was just looking at. You can just drag that over here onto your pipeline design surface, and that didn't work. There we go. And you can just connect those. So now after I copy the data, I'm going to then distinct that data set. And that's it. And then at the end of that distinct rows, that is going to output back into your data lake or your blob. All right, that was really fast. I apologize for the quickness of it. I have about 5 minutes left, so I think I'll go over into questions, and I might need Crystal's help in finding out how to find the questions on here.
Hey, Marcia, no problem. If you see on the right-hand side, you'll see like polls, handouts, and chat.
Let's see.
Questions. Do you see it?
Hang on a second. I'm trying to. So this would be under.
It's on the little like go to webinar panel screen where you can like mute yourself and.
Sure. I think I'm getting there. Give me a second. First of all, hang on, I'm getting there. Give me a sec.
Nope, you're completely fine.
Oh, you know what? Let me. I tell you why. It's because it's everything was minimized on my screen here. Okay, so webcam no, audio no. There we go. I'm actually not able to bring it up on here.
Okay.
Oh wait. Never mind. I got it. Here we go. I'm good. Okay. Let's see. So questions. That's all about the sound. I'm not gonna worry about that. I cannot hear. Oh my gosh. 2 questions. Here we go. On the first, okay, here we go. So on the first data warehouse ETL flow, can you elaborate how to load the data from data lake to DW? Since data in lake is in raw immutable, and at what point does ADF Databricks converge, as there seems to be some overlap? So real quick on that. So the first one is when you're loading tables using ADF, if you're going to load tables into DW, that's obviously a database, that's fine. If you want to use data lake as your target, you would essentially use, we recommend you use Parquet, and then you would use partitioning of those folders. So what happens is every time you get a new value, that value is added as a Parquet file, and that becomes something that you manage the version of those. So the same row would be inserted, and that version number becomes incremented, and that becomes the latest version of that data, of that row. All kinds of different sort of strategies on how to manage data lake as a data warehouse. And it definitely does not have the same sorts of indexing and capabilities that a data warehouse has, but it is possible to do that. And then on what point does ADF and Databricks overlap? Really, it overlaps in this area in ETL. If you, just stepping back for 1 second, if Data Factory itself also has full support for coding these sorts of data quality and transformation capabilities. So what I showed you was data flows as a visual interface that you could build these very quickly and easily and then execute them on Spark. But if you are savvy enough to work with Databricks, you could code it yourself and run it as a Databricks activity. Okay, so when can we expect Visual Studio IDE for ADF? We do not have plans to backport Data Factory into Visual Studio. We plan on moving forward with a browser-only interface for Data Factory. Bob Ross, there are no mistakes. There are only happy accidents. Is that it? I believe is the right one there. Wrangling data flow question. Data flows use only Power Query. Yes. Wrangling data flows use Power Query online, and then when you go to execute, oh, I didn't show you the script. Let me show you the script. When you go to execute it, there is a script that is generated. That script is the same script that gets generated for mapping data flows. And that script is from the script button in your data flow. And you'll see the full definition of your data transformation there. This is what gets sent down as a payload to Databricks to execute. And that gets generated for you from the M code in your Power Query. The movies data set, I meant to put a link in the slides. If it's not there, I'll add it before you get the slides. All the sample data is available to you. And data flows, is there any way to do ETL? Yep, this is all ETL stuff. To me, data flows inside a Data Factory is an ETL tool. That's the whole kit and caboodle. Can we use existing Databricks cluster? No, the Databricks cluster that's used for data flows is all embedded within Data Factory. We manage that environment for you. You don't use your own Databricks. If you want to use your own Databricks, you have to code using Python, Notebook, Scala, whatever it is, Java, and you can do that and execute, and you can manage those pipelines of Databricks activities if you'd rather. What is primary difference between lookup versus join activity? So lookup activity is really looking for reference data. The lookup activity, the terminology, just to be clear on this, the terminology in data flows is join and lookup transformation. We have a separate lookup activity that produces JSON output from the pipeline. Within data flows, join is inner, outer, cross join. Lookup is for reference data. Right now, the lookup is very, very similar to join. We are adding new features to lookup, like single row lookups and sorting. That's going to come out next week on that. There was one down here asking me for something. Some discussions. Of course, anybody can reach out to me anytime at all. Use the if clause filtering NA. Why does Microsoft complicate things with if and T-SQL and ADF? Because I don't know why we do that. I wish we wouldn't too. Apologize for that. ADF costs, oh boy. There was a great session, by the way, on YouTube from Inspire that Catherine Williamson did. That's I would recommend you looking up. And I think I'm just about at the end here. A lot of people asking for the recording and the slides. And when we build our own notebook from ADF, which cluster does it use? It uses Databricks, and it will use your own Databricks on there. Last one, will there be self-hosted integration runtime for data flows? No, we're not going to use self-hosted integration runtime. We did release this week managed identity support for SQL and for ADLS Gen 2, so you can access your private, your non-public storage accounts now without needing self-hosted integration runtime. Whew, all right, I'm done. Chris, I think that's it.
All right, perfect. Mark, I just want to say thank you so much for taking the time out of your day and to host this webinar. We greatly appreciate it.
You're welcome.
And as for the people in the chat that are asking about the recordings and the PowerPoint, yes, we can send you guys both. And the recording will be in your inbox tomorrow around noon. But if you guys have any questions other than that, please feel free to reach out to Mark or myself. We'll be happy to help you. And as before, all the recordings from any of our webinars are on YouTube on our page at Pragmatic Works. So please visit that. Like I said, you guys will receive the email tomorrow at noon, but hope you guys have a great day or evening. Again, Mark, thank you so much for hosting. We greatly appreciate it. And you guys have a good rest of your Tuesday.
Thank you. Bye.
Bye-bye.